So I'm actually really happy to be here. I've been at Red Hat for 12 years, so I've seen the good, bad, and the ugly. And actually it's pretty cool to actually be at a PuppetConf now, because the first time it was actually was introduced to Puppet wasn't really by happenstance. It was back in 2006. Red Hat holds what we call the Red Hat Summit, and I think 2006 was actually when we started our conferences. That was probably about this size when we began. And that one was actually down in Nashville, and what was interesting about it was we were actually in search of configuration language, a way to sort of model systems, and the reason we were is because you think about it, like, as much as Luke's talking about, like, how do you manage all these disparate systems from, VMware to Linux to Debian? Our customers were struggling at just sort of managing, Red Hat Enterprise Linux. And so you think about it, like, every time we do a version, we have to maintain that version in the wild for 10 years. And so just sort of the number of versions, we have something upwards of like 32 different kernel streams that are supported in production in our customer environments. Because customers, naturally don't want to move forward unless they really have to. So in 2006, we're like, we need a modeling language for a configuration capability that actually can manage all the heterogeneity, even in just the Red Hat Enterprise Linux sort of space. And we wanted to be able to flash applications and OSs in a really independent fashion. And actually, one of the engineers that we had assigned that was a guy named David Ludicord, who's actually now working for Puppet. And we had looked at everything. David had looked at everything back then. I looked at, obviously the lead technology back then was CF Engine, but it just didn't have the flexibility we wanted. And so that was really when we discovered what Puppet was back in 2006, and I had Luke living down there back then. I actually got to meet him while I was down at the summit. So to go from, which seems it's been 7 years, but it feels like 70, to go from sort of that day to actually seeing, Puppet thriving here. It's something that we really care a lot about at Red Hat. And so what I'm going to talk to you today about is about a lot of what we're doing in the cloud technologies. But a part of that, inside a lot of that is technology coming from Puppet Labs, and I'm going to try to show you where all that sort of plays in. I think it's a really hard time it's a hard time to be a systems vendor. It's a hard time to be a customer. We're in sort of those lean, mean environments where the expectations on businesses and IT departments are really high. Sort of right now, look at sort of the world. I don't think it was the same way even 10 years ago, but now you look at it, like when we talk to IT departments, they're trying to figure out what they do for big data systems. How do they take advantage of public clouds? How do they build private clouds? And so they've got all these initiatives that it's hard to even have the resources to do proof of concepts, let alone deploy something at scale. And they get rewarded by that by either having like a flat budget or in most cases, a shrinking budget. And then the budget that's left, right? You always hear the adage, right? About it's not like these companies actually get a do-over. 80% of their dollars are going in and just maintaining their existing applications environments. And it makes a lot of sense when you start to think about it, is that, that in today's sort of world, the lines of business, it's all about businesses are creating systems of engagement with their end users and their customers, right? And so how do you do that? I mean, software powers that. Whether it's software running inside of the fort or whether it's software running on publicly hosted services, that's how you engage your end users. And so that makes, sort of the developers the king, right? So the developers are the ones that are responsible for building these applications. But the challenge is that, when I was, started in computer science, you were writing your application on your workstation under your desk, and then you just sort of transported it to one server in the data center, and that was it. These days, our developers, even, especially inside of Red Hat, they need hundreds of instances, at their fingertips in order to sort of write their applications, and they need to have load balancers and databases and everything else. And a lot of the software stacks they're using inside of their applications, things like NoSQL databases, a lot of that technology didn't even exist 5 years ago. And so IT sort of is in the middle of all that. It's really difficult to meet the requirements coming in from the business and meanwhile sort of supporting what the developer needs. And we view that as a cool problem to have, right? So that I think when we sort of started out, I mean, a lot of the positioning of Red Hat and other companies and open source software was just as replacement software. It's like, how do you take something that existed in the proprietary fashion, rewrite it in open source software, make it free or near free, and then and give it to users. But the problem with that is that all you've really done is really sort of driven the cost down, right? You haven't really changed the capabilities of what your end users can do. And so we turned the corner on that, over 10 years ago, and we said, you know what we need to do is we don't even want to look at what the other vendors are doing, right? And we don't want to just come into a customer environment and see what they have, and can we make a business out of building an open source version of that? What we actually do is we actually spend time with our customers just observing, right? Just going in and seeing how they do things, and actually coming up with sort of new capability. How do we actually allow them to do something in the future that they can't even do today? And how do we actually make a big impact on their IT environment? And I think open source is sort of leading the charge of just about all of that. When you look at some of the logo charts, I mean, a lot of this technology, almost all of it doesn't fit into sort of that classical category of something that existed in proprietary. A lot of these technologies, the reason they're being used is because they allow you to do things in an integrated fashion that you otherwise couldn't do. So sort of shifting gears into sort of IT architecture and sort of where Red Hat is going and the IT architecture that we're working on bringing to our customers, we saw that back over 10 years ago that the move towards commodity computing was happening, right? Sort of, it's obvious now, but it wasn't obvious 10 to 15 years ago that x86 was going to be more than just a toy. That x86 was going to be the premier platform for running all applications. But we're seeing the exact same thing happening in storage and network, albeit slower, but we're seeing that move in IT to actually run your storage solutions, your networking capability, and your applications, all on that same common backbone, all on that x86-64 system. And there's still a lot of innovation that's happening inside of hardware, but now you're able to consume it in a standardized platform, which is really important for customers. And what that means is it's back to software is king, right? So software is king for actually building IT infrastructure and storage and networking services, on top of these common x86 platforms. But the challenge that we had before is that's great, so now you got silos for compute, storage, and network, but how do you actually knit it all together into a unified fabric, right? And so we were searching for that, and we actually had been making a lot of investments in, I'll call it a proprietary architecture. Even though it was open source, it was still a proprietary architecture in that we hadn't been able to create sort of that, collaborative development process around it, even though the code was public. And so Red Hat's completely pivoted on OpenStack, and we're using OpenStack as that framework for how do you actually knit together compute, storage, and network into a unified architecture. And we didn't join it for the first 8 or 9 months because it just was getting off the ground. Open source matters to us, but it's not the only thing that matters. What really matters to us is what you see here and what Luke was talking about, is that the reason we put code out in open is because we want to actually get users and developers involved. And OpenStack achieved that after about 9 months to a year. It really sort of created not just the really beginning of some rudimentary systems, but the developers that got involved and gravitated to it were well beyond any company. So we got involved, and now we're the #1 developer of OpenStack. That isn't the end game. That's just because we're so committed that OpenStack is that architecture that's going to redefine IT. And so it works really well, and so you sort of go back into that compute, storage, and network. The way OpenStack is, I think there's 9 core projects today, and they all map really well onto the compute, storage, and network backplane. And the first, from a compute perspective, it's kind of what you would think, right? So it's a lot of times you get sort of hung up on sort of the difference between virtualization and cloud, and the one sort of compelling difference is what OpenStack's doing is it's putting an API around everything so that everything can be automated. And all the capabilities actually has a plugin supported architecture. So on the Nova side, which is sort of the managing the compute tier for OpenStack, it does the most simple thing, is what you'd think about. Oh, I lost my downside. Oh, that's okay. It does the simplest thing that it does is that it gives you that API to create VMs. And then, of course, because it's cloud, you don't own the VMs. The assumption is that you're going to use the VMs when you want, then they're going to be released back into the pool and be used by somebody else. So it's a very dynamic, elastic environment. But it's going beyond that. So the Nova technology started as just sort of VM provisioning, but actually now what it's doing is there's 2 other things that are happening. It's now able to provision containers. So instead of just handing a full heavy VM, you can actually just take a lightweight slice, a secure container out of an existing VM, and you can actually have a better utilization model. And then in addition to that, it's getting a little recursive because OpenStack is you can actually deploy a little tiny footprint of OpenStack and then use that to actually install OpenStack itself, a larger scale. And that's this thing called OOO, which is OpenStack on OpenStack. And we've got some ongoing work right on that to actually make that, allow Puppet to integrate with OpenStack so that OpenStack provisions OpenStack. It uses Puppet and RPMs. And so I wanted to show you a video of our IT department. We're actually a big customer and end user of Puppet. And it was really, as we started to, like many of you, started to, in our IT department, not just in our product side, to use virtualization more heavily. All of a sudden you went from hundreds or thousands of physical servers into the thousands and tens of thousands. And so Puppet is a big part of how we actually manage that. You can roll the video.
So we started using Puppet in general, looking for a configuration environment where we can have some consistency across building out our physical hardware. We pretty quickly got into virtualization, and it extended nicely there as well. It let us consistently build new systems from an infrastructure perspective that we can roll into our data centers.
We've seen tremendous growth at Red Hat over the last several years, and this facilitated our entry into Rev-based virtualization, which for us took us from, during that time frame, a few hundred systems to a few thousand systems today.
Puppet and configuration management that we've been able to develop with Puppet has made it much more consistent for us to go from development all the way to production. It's also increased our time to market dramatically. We can build out environments, new environments, and then replicate those all the way to production fairly easily.
We have a certain set of base modules that gives us a high degree of standardization, a high degree of reuse for those modules to avoid duplication of effort.
It's also given our application developers significantly more control over their own environments and given them kind of the ability to pick the modules that we have within our Puppet library for what they need to develop and not have to reinvent the wheel every time.
With Puppet, we've been able to have that standard platform and provide the consistency as well as the management tools that we need to take us into the next generation environments with cloud.
Without Puppet, we could not have grown like we have.
On the storage side, there's actually two core storage services as part of OpenStack. And a lot of OpenStack increasingly is moving to a more pluggable framework. So the idea would be, hey, I can have a storage service that's pluggable, and then I can implement that with either some proprietary technology, some hardware, open source module. Storage isn't quite there yet. There's two sort of default sort of core projects for storage in OpenStack. The first is sort of what you need to get started. It's an object storage service. And the reason you need that is because that's where the VMs are stored before they're activated. And so that way Nova goes and pulls the VMs out of the object storage service, which is called Swift, to actually deploy them. And then the second part of it is, and you can use that, it's very S3-like, so you can use that for other things that you would use a normal object service, throwing backups or pictures or images or whatever you might want. The other piece is sort of once your VM's up and running, it's great. It's sort of like how Amazon started. It's great to have ephemeral storage, but if you actually want to, shut down your VM and actually, actually resume where it took off without starting all over again, you really want a persistent, backing plane for block storage, and that's what Cinder is. So the Cinder project is a distributed block service as part of OpenStack. What Red Hat did is another open source technology that we have for distributed file services called Gluster is an acquisition we did almost 3 years ago, I think now. And so we tend to add that to our OpenStack deployments for customers, and that adds sort of an important third leg, which is files, right? So when you start thinking about cloud, you want your app instances to run on any node, and you want to be able to pick the node on demand. So you need that distributed file namespace so that every app can see a consistent view to files. And then in addition, sort of that file service itself needs to be just like, they were talking about, the gentleman from Google was talking about, you need the resiliency that, if any node in your storage services fails, that file already has other replicas so that you can get at it. So you can build this highly available cloud service, and then that system itself can grow as you need either more storage or more bandwidth. On the networking side, the original project for OpenStack was something called Quantum. Turns out that that's actually the name of a company, and is not a good thing to do when you want to own a trademark. And so it's now been renamed Neutron. So Neutron is the API, if you will, in support of networking configuration inside of OpenStack. And today that's a very pluggable architecture, and what it aims to do is it's just the recognition that the networking topology inside of IT data centers typically is too static, right? So if you're starting to build these, if you want to be able to put compute and storage wherever you want, connect them together, then you need a network fabric that supports that. And sort of the old model of build your data center, put in your racks, put in the top of rack switch, deploy physical servers, and on a physical server put an OS and app, and there they stay, for years just is over. So now every physical server typically is virtualized. So you need to be able to have a networking configuration that works as dynamic with your virtualization system. And that's really what OpenStack is, the Neutron capability is aiming to solve. And it's got a couple of parts to it. So it naturally presents sort of an SDN-like interface to networking configuration. And then you can plug into that. And it typically either works with a physical switch with like an OpenFlow API in front of a physical switch. So it can manage physical switches, as well as what's happening is now there's this new breed of software-based virtual switches that run actually right in the host compute node. And so in OpenStack, there's a project called Open vSwitch, and that's something that we deliver inside of enterprise Linux with KVM. And then all of a sudden, that endpoint that's running lots of VMs has the notion of virtual switching right inside of it. And then once you have that sort of fabric, then you can actually, your networking configuration is no longer dictating where you put your apps or where you put your data. You can put your data wherever you want because you got software-defined storage. You can put your apps near the data. You can put your apps near your users. And then the network configuration follows that. So you can reconfigure the network and build an overlay network on top of the physical infrastructure. So we did one more thing once we joined OpenStack, not just contributing upstream. We've got really a mantra inside of Red Hat called Upstream First, and it's more of a methodology and what we believe makes sense than necessarily a hard, fast rule. And what that really means is that, anytime we make changes to our products, we don't try to differentiate based on the product. It's important for our developers to get technology upstream and publicly used before it ever finds its way into a customer environment. So we try to do that in almost all cases where that applies. But there's another important piece of that. So we develop publicly, but then the products reach the hands of tens of thousands or 100,000, right? What that means is there's a gap in the middle, and what we often create is what we call community distributions, and the community distributions sit in between that. And so OpenStack was kind of missing one of those. I had a great, vibrant upstream, and then a lot of vendors are building product, but we created RDO, and what RDO is basically, it's really like a real-time packaging of what's happening upstream in OpenStack. So soon it'll be on like a patch-by-patch basis. So not just the end release that takes 6 months to build, but like on a daily basis as code is submitted inside of Upstream. How do we actually package that in RPMs and make it consumable on any enterprise Linux, CentOS, RHEL, Oracle Linux, SLES? And then the idea is then you can get an OpenStack distribution, something that was developed in real time in the hands of millions. On another side, on the Open Daylight side, what happens is also what's starting to happen is when you build these large-scale environments, you need a distributed. There's these new classes of software-based distributed networking switches, right? And they can plug right into Neutron as well, and that helps you manage when you get thousands of systems deployed in data centers. Like, how do you really manage the networking topology? And Nicira was really the pioneer behind that. And they have a software-based distributed switch that plugs into Neutron. And then also there's most recently it started this winter, there's a community project, community collaboration called Open Daylight it started with a code dump from Cisco that is also building a distributed switch based on open source software. And so our lead developer and our board member for Open Daylight is Chris Wright, so he'll talk to you about the project.
There's exciting change happening in the network industry right now. Moving from vendor-centric solutions to open solutions, APIs that allow for programmatic change to your networking infrastructure, all in the context of adapting to the requirements placed on the infrastructure by cloud computing. My name is Chris Wright. I'm the Technical Director for Software-Defined Networking at Red Hat. It's been probably 2 years at Red Hat where we've been defining for ourselves the problem statement, which is how do we manage networks in a cloud context or a virtual context. It's that mindset that brought us to the Open Daylight project. That's an exciting part of the industry. So the networking in general has not been moving at the innovating or changing at the same pace as the rest of the industry in response to virtualization. Now we're seeing a variety of solutions, people who are looking at pushing more and more of the fabric or networking infrastructure's intelligence out to the edge, and equipment providers who would like to see their portion of the industry or the market to remain relevant. The Open Daylight project is an industry consortium whose goal is to produce an open source software-defined network controller. So an SDN controller gives us an API which allows us to programmatically control the network infrastructure, giving us the ability to accelerate or rapidly respond to the dynamic workloads that come along with cloud computing. One of the needs driving the network transformation that we're seeing take place is the ability to fundamentally decouple your application workloads from your physical infrastructure. We saw that play out in server virtualization, and we're seeing the same thing happen in network virtualization. You break down the barriers to rapidly adapting to dynamic workloads. Open Daylight and OpenStack are connected via the Quantum project. So Quantum provides the networking services for OpenStack. It relies on some underlying infrastructure to actually manage the real networking elements in the data center. Open Daylight is that project that can manage the real networking elements in the data center as driven by Quantum. In the next year, I think from the Open Daylight project, we'll see a functioning controller, we'll see integration with projects like OpenStack and Quantum, which is particularly interesting to Red Hat, and we'll see a number of different layers sitting on top of that initial controller that we hopefully will see released from the Open Daylight project within this calendar year.
So now IT can build these infrastructure clouds, right? So what that means is developers are no longer waiting on physical servers, right? They're getting their VMs on demand, but it hasn't necessarily really changed the game all that much because now developers are still dealing with VM containers, provisioning OSs inside of those VM containers, and understanding cloud interfaces. And so because of that, the business is still impacted. The way, the best example that was given to me by a customer of ours was they actually did an experiment where they had a young developer that was new to the company write a really simple application, a Hello World application, which obviously took minutes. But what happened though is then they wanted to get that application deployed on their public-facing infrastructure because this company was all about creating engagement with their customers. And they needed apps deployed, as quickly as possible to be competitive. And so it took minutes to write the app, and it took them over 3 months to actually get the app deployed in a reliable, scalable way. And this is a very modern company. And really, this is sort of the model that you want to get to, right? This is the model of DevOps where you really want, as the application is being developed, it's being developed and not just continuously integrated, continuously deployed in that exact same environment in which IT is going to deploy it in production. And that was really what the genesis was behind, us starting Openshift. 3+ years ago, it was called Libra. Another thing hard to trademark. We didn't know about platforms as a service back then. What we did know is that our own developers weren't ridiculously productive, and we knew that they were worrying about servers and cloud interfaces and packaging software and transporting them up to Amazon. And we said, we can make them, super productive by changing the model. And really, the model was like, let them just develop code. And let them develop code in their own sandbox, whether it's Git or using Eclipse, and then let OpenShift come in and just with as simple as a Git push, take that code, package it, transport it up to the cloud, wherever that cloud may be, run it through continuous integration, build it if you have to, deploy it, find a free slot in the cloud, whether it's a VM or a container, set up the security infrastructure around it, the monitoring of the resources, plumb the DNS, build in auto-scaling. That was what OpenShift is all about, is actually putting that in front of developers so that they're now developing in the same model that IT wants them to deploy in and make them efficient. So one of the most recent features was how we added continuous integration in OpenShift. And so I want to have one of the developers actually tell you how he did that or how that's used.
My name is Brenton Linhart. I work on the OpenShift Enterprise product here at Red Hat. Although I've been here 8 years, OpenShift Enterprise is changing the way I do development. One of the game changers for me is really how an application can be cloned from a production environment into a sandbox, complete with continuous integration in a matter of minutes. In my case, I create a Ruby runtime environment, add a database, and clone my production web service in a matter of minutes. When I say clone a production web service, that's actually what I mean. I'm adding a Git remote to my repository that contains the code, then I merge it as I would any other code. When I finally push the code to my sandbox, Openshift downloads the dependencies, builds my code, runs my database migrations, and starts up the service. From there, my app is ready for use and I'm ready to add continuous integration. Thankfully, creating the Jenkins server is the same process as creating any application in Openshift. To integrate my web service and automatically create a job in Jenkins, I simply add the Jenkins client cartridge. It's important to realize that this is the same Jenkins that the community is already using. This means you can configure the build script however you want. For my projects, if the tests fail, the deployment is aborted. When the tests pass, it ships. It's pretty simple. In fact, Openshift makes continuous integration so easy, there's really no excuse not to have it. This is really just the tip of the iceberg. You can start working with Openshift Online today. You can deploy Openshift Enterprise at your company. And the truth is, you don't have to modify your application, but you will change the way you develop your software.
You know, it's a great way to sort of measure how good software is sort of like you can do marketing data sheets and talk about features, but to be honest, the best part about working in open source and actually running a free service on top of Amazon's cloud is that one way we can measure is not just with downloads, but users that are actually using the system. So this is sort of the most recent stats. These are over the course of a month. And right now we're averaging 2,000 new apps created each day on top of OpenShift, which is up and running on top of Amazon. So this is sort of where we want to get to, is sort of that, that developers are super productive. They're not worried about clouds and interfaces. They're just in this, they're working in a really efficient PaaS environment. Lets them focus on application logic and not infrastructure. Obviously that's going to feed lines of business because now they can get past that 90 days to deploy and actually be able to deploy in real time. And it's delivered by IT. Instead of IT being in the middle and being the impediment, IT is the one that's building these systems of integrated infrastructure as a service and platforms as a service. And the best part about it is it's all delivered on open. So thank you.